Hey, in this video I want to talk about the difference between key events and key states. And this idea applies to all sorts of hardware when you're getting input from the user. So I'm in Visual Studio and I am looking at just a ball demo you may be familiar with. Let's see. You run it and just a circle moves on the screen. So what we have here really that's important is that an object is moving. And that movement happens because we're taking its x coordinate and its y coordinate and just adding some value to it every frame. The details of how we're drawing it and everything are not that important for this video, but we are using SDL, the Simple Direct Media Layer, so some of that pertains. So I have in my main, I just have a couple of variables for like the position of the ball and its velocity. And that update ball function is being called so that that velocity is applied to the ball's x and y coordinates. But I'm going to comment that out for now. So the ball just sits there and doesn't move. And then we can look at the two different ways we can detect input from the user, particularly with keys on the keyboard. So we have this event loop. While SDL pull event will loop every time that we have an event to process that's still on the event queue. So if the user like mashes a whole bunch of buttons all in one frame, the queue, it gets loaded up with each of those presses in the order that they happened. And then we have to process all of them before the frame ends. And that's what this loop does. So each time through the loop, we're processing one event. And one possible type of event is a key down event, SDL key down as the event.type. And so we can check for all sorts of different keys. If event.key.keySim.sim, it's a lot to type there, but it's the event's key structure, and then we're connecting to the keyboard symbols and the particular symbol for the event that happened for the button that was pressed. We check to see if that is, let's say, W. So SDLKW is a code that represents the W key, and I can do something like maybe ball X or ball Y, let's say. Minus equals 10. And I can do this for all of our friends on WASD. So let's do A is to the left, S is down, so let's add 10, and D is adding to the X coordinate. All right, let's try that out. So WASD here should work for us. Okay. All right. So, yep, we've got some movement, but it's blocky, right? It moves only by increments of 10 every time that I press the key. And if I hold the key, let's press and hold D, it happens once, and then it has a delay before it starts repeating. This is just like in a text editor. If you press a key and then hold it down, it will it'll give you one letter on the screen and then start repeating it. But this isn't really satisfying movement for a game. This is great for typing in text and stuff, and if you want to press individual keys, you can do that. There's also a way you can check if the key wasn't repeated. There's like a if event.key. Where is it? Repeat. So let's say if not repeat, then we'll do all this stuff. And this will have the effect of disabling the repeat, so it only happens one time when you press the key, and if you hold it, nothing happens. So that could be useful, but in our game, I want some smooth motion. So I'm going to take this out. And instead of responding to events, where events are when you press the key or when you release the key or when the system wants to send a key repeat, those are all events, things that happened. But what I want to check for is the state of the keyboard. What is the keyboard doing right now? So if you have this line, this line here using the SDL get keyboard state function is getting an array that holds the state, either on or off, pressed or not pressed, of every key on the keyboard. So this key states array then is something I can check if I know the right indices to use for each key. Now I can scroll on down. I'm going to get below the event processing loop, somewhere out here, not too important where, but I can now check that key states array. And I have to use scan codes here. So SDL scan code underscore, and then you can see all the different scan code options. And these are, again, all the keys on the keyboard and some. So let's say W. And for scan codes, for some reason they use capital W. Let's say scan code W. Let's do what we did again. Let me just grab this. And I'll directly replace it. So there's W. This is going to be A, S, and D. Okay, so now this code is going to be running every frame, no matter what. It doesn't depend on a key being pressed down or released. It's just checking, is it currently being held down? And if I do that every frame, I should get some sort of smooth motion. So here's D. Much better. So smoother, for sure. It's also kind of fast, and the units are tough to figure out. Because this is happening every frame, that means 10 units, or 10 pixels in this case, every frame is my speed. And 10 pixels per frame at 60 frames per second, assuming you're getting 60 frames per second, that's hard to figure out, like, how long is it going to take to get somewhere. What I'd rather do is work with units that I can conceptualize a little better, like pixels per second. And so if you are measuring the amount of time that a frame takes, then you can do that. You just multiply by the delta time. So I'm going to just take that times delta time. There we are. And now we're going at 10 units, 10 pixels every second. This DT is a small amount of time that's one frame of time, and so it's going to be a small slice of the 10 that gets added into my position every frame. And this is going to be rather slow. So 10 pixels per second means with a screen that's 800 pixels wide, it's going to take me like 80 seconds to get across the whole screen. Over a minute. That seems kind of slow. So let's change this. Could do 100, which would be, it would take me 8 seconds to get across the screen, which is fine. I can try that out. Yep, that's a little better. Could go faster, but that's fine. And another thing I can do here, because this is just either true or false, I can combine it using logical operators. I can say key states for a different key. Let's say scan code left for the left arrow key. And I might throw on the rest of these so that we have, let's say, A. A is actually the left arrow key. Let's say this one is up, left, down, and right. There we go. So now I can use arrow keys. Either one of these can be true, held down, and then we'll get that motion out of it. Great. So the last thing here to explain is that why are we using scan codes when we used SDLK, the SDL key symbols up here? The reason is because when you press a key as an event, you're expecting to get the key that has the letter like printed on it on your keyboard. So when I press W, I see the W on my keyboard. That's the one that I want to be sent as an event. However, when we're working with scan codes are working with the physical position of your keys. it doesn't matter what's actually printed on your key. It's pretending like or referring to the layout you have on a US keyboard. So you could go get a French keyboard, an AZERTY keyboard, and you could press the button where the W is supposed to be on an AZERTY keyboard, which it would happen to be the Z key. If you press the Z key, this is still going to work. You're still going to get the WASD pattern on your keyboard that lets you move, though it's not going to say WASD on your keyboard. So this makes it much more compatible for simple games, instead of forcing your users to remap their keyboard or get a US keyboard or something crazy like that. So scan codes refer to the physical position of the keys on your keyboard, and these key symbols are the actual letters that are being sent through to the system. All right. So hopefully that is useful to you. Think about how there's a difference between events that are happening and the state of hardware. You can poll the state and check what the state is, or you can try to process events. See you later.